This is Criterion D of my Computer Science IA, so I will be showcasing the product. So to begin, to access the Moonboard grader for my client, Sam, who's a climber, you can first just either click the link or paste in the link, which I have copied to my clipboard, into any browser. So as long as it has access to the internet, this website will be accessible. So within the website, you can see first off, it displays the Moonboard, and while it's not the most aesthetically pleasing, it looks much more fitting to the screen on a phone, which is the primary target of when this product will be used. And you can see there's the Moonboard, there's an empty list of coordinates, and two buttons, namely grade, climb, and clear. So what you can do on the website is you can select holds by clicking them, and you can see it highlights them and stores the coordinates in a list, which is also stored as an array in the JavaScript. And you can click the clear button to empty the coordinates list and clear the board. So if I want to grade a climb, then I will first select these holds, and then I will click grade climb. But before showing what the grade response is, I will outline what's going on the back end when I click this. So I click grade climb, and I'll now outline what happens on the AWS server. So within AWS, there are a few main services that are essential for this project to run. The first I will outline is IAM. So what this does is it defines roles for basically the services to interact with each other and have the necessary permissions to share data with each other. So the main role I use is this top role, and you can see it has administrator access and also access for code pipeline and Elastic Beanstalk, so those two can interact. Now over on Elastic Beanstalk, I've created an environment within Elastic Beanstalk, which essentially allocates a server on EC2, which is Elastic Compute Cloud, I believe, on AWS. So there is a server in North Virginia that's called in the zone US East 1A that is basically allocated to my website. So in my environments in Elastic Beanstalk, I can click the health, and this instance is essentially the server with EC2. So Elastic Beanstalk basically abstracts a lot of the intricacies of manipulating EC2. So I can show that this instance is T3 medium, which is basically how much computational power it has, and there's the server. Now, moving on to code pipeline. This is basically what allows Elastic Beanstalk to interact with my GitHub repository. So here's my code pipeline, and what this basically does is it has the source code, which is the GitHub repository I've given it, and it has the domain of the Elastic Beanstalk site that it deploys the code to. So now going over to my GitHub repository, this is what is being run on the Elastic Beanstalk instance. So it should first be noted that these have defined names that Elastic Beanstalk is aware of. So it knows that an application.py file will run a Flask application. So it knows what to deal with that. And the static and templates are essential for Flask to know where the HTML, CSS, JavaScript, and other files lie. Also, the git ignore file tells Elastic Beanstalk which files to ignore in when it's trying to figure out what it needs to install to run the application. And the requirements.txt file is also has a defined name that Elastic Beanstalk knows which Python packages it will need. So this is good for its extensibility as it has well-defined names. So beginning with the static files, there's the JavaScript, the Moonboard image, and the styles. The most important is the JavaScript, and the JavaScript waits for a click of the grade button, and when that happens, it uses the Google Ajax API, and it sends a post request to the URL at grade climb with the coordinates of that the user has clicked. And what that then does is, in the application.py file, it waits for a post request from the grade climb URL, and it stores the data into coordinates, and then it calculates the grade of these coordinates with the calculate grade function. And the calculate grade function first loads in the network from the pickle file, and it reformats the climb data, and finally it returns the predict neural network function of the given the network and the climb. And predict neural network is within the network evaluation file, and it basically just runs a forward propagation on the input climb. So this climb, or this grade, sorry, is then returned to the grade climb function in the Flask application, which then returns the grade all the way back to the JavaScript file, which then here updates the grade button on the website to display the grade. And again, this is all being run on the EC2 server, and you can see as we come back, it graded it as a V5, which is a relatively intermediate grade, which seems fairly accurate for this climb. I am here at the Moonboard with my client Sam, and we are going to be going through the success criteria for the Moonboard app. For success criteria 1, would you say it gives sensible grades on all climbs?
I would say so.
For success criteria number 2, would you say it generally grades as good or better than you?
Generally, yeah.
For success criteria 3 and 4, would you say it is an easy and clean website that allows you to input new climbs?
Yeah, I can click the climbs I want, and it just shows up.
For success criteria number 5, would you say it allows for unrealistic or illegal climb starts?
Unfortunately, I would say that it does. It allows for some interesting climbs and some interesting climb starts that you wouldn't see on the Moonboard.
And for success criteria 7, can the app generate new climbs?
It unfortunately cannot.
And as you can see, for success criteria 8, you can use it on your phone as long as it is connected to the internet.